Okay, this is 2008 paper, question 5, and we're looking at an amplifier question. So this is the graph of V out versus V in, or V out versus V in. It's usually V in this way, V out that way. What was the voltage amplification of the transistor amplifier? So voltage amplification, like I don't really, you won't always know what the terms mean, but that kind of makes sense. It sounds like the gain. Sounds like the gain. And how do we figure out gain? It's the rise over the run. So the rise is 3 volts. The run is 60 millivolts. 3 over 60 times 10 to the negative 3. So we're doing that in volts. If you're uncomfortable with this, we can remove that. We can go 3,000 millivolts. That may be easier for you to use. Because when we cancel them, we don't even have units. Voltage amplification doesn't have units. Because the volts cancel. We're just left with a number. Like a number of way converting millivolts in times some number gives us millivolts out. So anyway, 3,060 equals 50. 50. Explain the shape of the graph in figure 4 in terms of the operation of the transistor. Explanation to why there's a negative slope, why is it horizontal sections at V in plus 60 millivolts and V in minus 60. And how many marks? 3 marks. So we'll try and get 3 points down. Well, they're kind of giving us what we should be doing. Negative slope is due to amplifier being an inverted one. Inverted. Or inversion amplifier, inverted one. And then you could probably go on to say output would be opposite to input. Something like that. But the key words are inversion or inverted. Yeah, inversion and the negative slope. So they're linked. Why it has horizontal section. So I'd like to explain, if we're explaining the entire shape, we could also talk about the linear section. In the linear section, V out equals V in. It's not always like that, but we just go times gain in this situation because it goes through the 0. Or we can say V out linearly increases with V in, because that's what happens in this linear graph. And then we can talk about the horizontal sections and say that horizontal sections, I'm just going to put the keywords in instead of writing everything. Horizontal represent clipping, distortion areas beyond plus 60 millivolts and minus 60 millivolts is the range of the amplifier, of V in of the amplifier. Beyond that, you get clipping. That's essentially the main ideas. Okay, so that's roughly that. Now they want us to sketch a graph. This is our V out, and this is our V in. So to sketch this graph, we have to know a few things about the amplifier. Okay, because this is essentially, we're taking this V in, we're sticking it through the amplifier, what's going to come out? So first we know the amplifier is inverted. So that's always important. Is it inverted or not? Yes, it is. So it's not going to look the same. Next, we need to still figure out the shape. Is it going to be clipped? And where is it going to be clipped? So our maximum voltage in is 100 millivolts. If we look here, 100 millivolts is too far. It's going to get clipped by the time it reaches 60. So it's going to be clipped around here. So now we have a better idea of the shape. Clipped at 60 millivolts on here, or at this time. And finally, we want to know what our scale is. And so we know the maximum V out is 3 volts. So scale. So inverted, is it clipped, and what's the scale? So we know it's inverted, we know it's clipped, and we know the scale is 3 volts. So inverted, it's going down. Where do I want it to meet again? I want it to go through 0 here. 0 here, 0 here. 0 here, 0 here. Okay. Now it's going upside down, it's going to get clipped around there, and it goes to 3 volts. It's easy once you get some practice at it, but you just consider those 3 things, and then you're great. Yeah, and that's it. Awesome. So we're going to go through, and that's all of amplifiers. So thanks for that.